morning, good afternoon, everyone. Uh, my name is Vikram, and I'm the senior sales engineer for VMware Carbon Black. Been working with Carbon Black for almost 6 years, and been with endpoint security for almost 16. Mostly focused on AV, EDR, app control, container security, etc. Right? And today I'll be talking about VMware App Control and more from an Essential 8 perspective of how do we get quickly to maturity level 2 so that we have enough time to move to maturity level 3, right? So with that, I'll just quickly start. Today's agenda is more about understanding what's Carbon Black. Then we'll look at the requirement itself from ACSC of the Essential 8, of how do we identify the files, what is content-based inspection, some examples. Then we'll look at the architecture of the product itself and ways you could approach the implementation, summary, and then we'll go for Q&A. Now, when we talk about the overview, let's go back and start where it started, right? So even back in 2002, we realized AV is not enough. And there was something required that was completely opposite of antivirus. And that was like a firewall, which only allowed approved applications, right? So we got a $2,000 grant from NIST back in 2002 to build something completely opposite. And that's where Bit9 was found. And this solution got to be named as App Control. So we were the innovators, or we started the App Control. And then 2005, we added intelligence to it, reputation to it. So it was like, okay, all these files and hashes there, but what do they mean? Like, do we know anything about these files? So reputation helped with that. Later in around 2011, a company called Carbon Black was founded for EDR threat hunting. We got acquired, Carbon Black acquired Bit9 around 2013. Bit9 acquired Carbon Black, and we changed the company name to Carbon Black. Then in 19, we acquired Confer, which was a cloud security solution. And in late 2019, we got acquired by VMware, and we became the security business unit for VMware. So we have 2 on-prem solutions and a cloud-native solution. So looking at the overall Carbon Black security portfolio, it covers both workload security and workspace security. That's like servers, desktops, containers, everything. And it starts from prevention, detection, response, things like your next generation antivirus, right? So starting from the left to right, your next generation antivirus, which is looking at advanced malware prevention, ransomware, things like that, host-based firewall, device control for prevention. From detection and response, we have EDR, which is looking at threat hunting, incident response, root cause analysis, things like malware detection response. Managed detection response is looking specifically at managing your environment, monitoring your environment is a service from Carbon Black 24/7, looking at attacks on your next-gen AV and not just detecting it, but also responding to those attacks in real time to contain that threat. From risk and compliance or audit identifying risk perspective, we have audit remediation, which is like a search engine for your environment, which is where you can search for things like compliance, like CIS benchmarks or any compliance requirements. You can run YARA rules or search for indicators of compromise on the computers. So there are multiple use cases for audit remediation, vulnerability management for desktops, laptops, servers, containers, everything. Containers, Kubernetes security is again looking at network and container security on the container security, which is again detection and response, right? For security on containers. Again, we have the 2 on-prem solutions, as I mentioned earlier, the Carbon Black App Control, which was the Bit9 solution, and the Carbon Black EDR, which was the original Carbon Black EDR solution. Again, for Australia, we have Australia POP. So it's based in Australia that takes care of the data sovereignty problem. And again, it can be deployed across Mac, Windows, Linux, any cloud, on-prem, or virtual environment. Today, we'll be focusing on App Control, though. And so before going into the product or how we can implement, let's look at the requirement itself. And this is directly from the cyber.gov.au, this link, right? So let's look at what is defined by App Control by them, or what is the main requirement, right? So it is only approved applications. And when they say applications, not just executables, it's software libraries, scripts, installers, HTML, application, applets, drivers, etc. Only those approved applications can be executed. The non-approved ones or unapproved ones should be blocked as well, right? So that's pretty straightforward. But also look at what is not an app control, right? So you can't have an email or web filtering, just filtering on the URLs that's downloading software or malicious softwares and calling it an app control, because that's not an app control. Checking reputation of an application before it's executed, that's just how normal antivirus works, right? So again, antivirus is not an app control. It's a completely different use case. Same thing with next generation firewall or anything on the network, right? So again, your web, email, network, they're not sitting on the endpoint. That means no matter what policy you put there, applications are still running on the endpoint, right? So that's not an app control. In terms of guidance around implementation is, again, you need to identify the approved applications first. You need to have the inventory, right? And that's the most difficult job, to have the inventory of all the applications. Then only approved applications are allowed to execute. You need to have a robust change management program. And what they mean by that here is, it's not a one-time thing that you implement and it's done, right? It's an ongoing process. That means any new applications coming in, any changes to existing applications, or any changes to processes needs to be approved by IT, and you should have the visibility of who is doing what and what has been done. Some of the ways or the common ways of implementation is, again, hashes, certificates or publishers, path rules, that's like the file name path to create those approvals. We'll talk about that a bit more. And then it's not just about allowing and blocking, but also having that visibility that every event that happens, it should provide context of what just happened, right? Like name of the file, date, time, username, or the user attempting to execute for the bare minimum, right? So at least bare minimum, it should have these, but again, the more, the better. Again, you cannot replace your antivirus or other security software with app control. Completely different requirements. This is looking at what only approved applications and scripts can execute. Everything else is blocked, but at the same time, not like bringing down the whole operations itself or impacting the day-to-day working of users and servers. Now, of course, there are like free. I won't call it free, but OS inbuilt softwares, right? So it's not free, but of course it comes with the OS. So OS inbuilt softwares with which you could implement the app control or the Essential 8 maturity level 2 or 3. But the thing is, it's not easy. It's not easy and is an understatement. It's damn too difficult, right? It's not just difficulty in the implementation. People think it's very difficult to implement. No, yes, it's difficult to implement, but it's more about the ongoing management. How do you do the change control? How do you do the exceptions? How do you take care of the new files coming in, new applications coming in? How do they automatically get approved, right? So again, making things easy is the most difficult things to do, right? And that's where doing that for 20 plus years helps understand the customer challenges, helps understand how they're using it or what exactly needs to be done. So a few clicks can solve problems that would take days to resolve. Now, again, throughout the years, from all the customers, because they have faced challenges implementing different solutions. So these are now common myths that I normally hear, which could be true for some, not true for some. It's really difficult to implement app control and needs a lot of resources to manage the solution. Well, yes, with a lot of other solutions, but we will talk about how we make it easy and how we make it easy for not just implementation, for management as well. Implementing app control would disrupt my running applications. I have so many applications, I don't even know. And if I implement it, it will just block everything. So we take care of that by something called initialization, where the moment you install the software, it will automatically create an inventory of everything that's on the computer, installed, standalone, everything, and it will locally approve it. Of course, you can change it later on, but it will locally approve it so that anything that was running does not get impacted. It will break any updates. So how do I get the OS updates or updates for Teams, Chrome, or those self-updating applications where the users have to update themselves? So again, we have the automation, or we have those configurations inbuilt where with just few clicks you take care of all these problems with something called updaters and rapid configs. How do I deploy the solutions? Like any software deployment, I need to deploy patches, I need to deploy any software, new versions, like could be like antivirus or any other software. And again, do I need to approve the hashes every time? Do I need to have a list of all the hashes? No, right? So the way we work, we trust what your IT deploys. Once we trust that, anything deployed with that is automatically approved as well. The developers have always been a challenge for app control, right? And this is historically, this is even in present, because again, they are not the normal users. They are creating new applications, and these applications sometimes signed, sometimes unsigned. They could be using different applications. So we have different ways, like things like just approving the Visual Studio as like for developers, so that if you're using Visual Studio with just one click, anything that's created using that automatically gets approved. Or there are other ways where we can work with you to understand the process and have a specific directory or self-approving directory just for the developers. Again, it can only block executables, which is not true. As we discussed earlier, it's, scripts and any other file types you can monitor and control. And this is, again, every time we have found it, like when we think we have the whole inventory from our SCCM, Intune, CMDB, or from EDR solution from different sources, most of the times it's not true, because it's not that it's not true, it's incomplete. The reason being is only looking for installed applications. So installed applications, it's not the full story. There are a lot of things like those sitting on someone's D drive, sitting on someone's USB, or those are single click applications, the standalone applications, and they get used a lot. And normally they are 3 or 4 times more than the normal applications. So having that inventory, having that visibility of each and everything that's in the environment that the user is using, to not to have to view it and then control it, right? If you can't view it, you can't really control it. Now, again, as I mentioned earlier, the first thing you do is initialization that takes care of any running applications on servers, desktops, laptops, Mac, Windows, Linux, so we are not disrupting them. Then after that, we have things like IT or cloud-driven trust. So even focusing on IT-driven trust is things like we can trust your SCCM or your GPU or your workspace one, the software deployment solution, so that we know IT will not be deploying malwares from there, even though I had been proven wrong once. But again, typically it's IT will not deploy malware or unapproved applications using these software deployed solutions, right? So you can trust that, and anything deployed from that automatically gets approved. And then same thing for your self-updaters. Once you approve things like Teams, Chrome's from, because it's IT trusted, the users can self-update without, logging a ticket or approving a specific hash. Trusted publishers, again, things like VMware, Microsoft, Google, Intel, or any other chipset that you're using, you would have different applications. You would even have your own certificates that you're signing your applications with, right? Your custom certificates for custom applications. So once you approve these publishers, so any file signed with this publisher, past, present, future, automatically gets approved. So you're not looking at file level, you're not looking at hash level, you're just looking from application perspective. Everything signed with that automatically gets approved. On the flip side, automatically gets banned as well. Things like, any unapproved software, like those freeware VPN softwares, or any of those software that you want to ban. Once you ban a publisher, any version of it automatically gets banned as well. So you don't have to think about, what if someone comes with a new version or changes the hash, changes the file name, it's all gets taken care of. Again, the rapid config is where we have spent a lot of our time in the last few years, where putting in all the experiences, talking to our customers, understanding the challenge, how they are doing it, where they're spending most of their time, or what they are struggling with, and taking that feedback and putting something automated that, when a single click can solve that problem, you don't have to spend days on it. right? And providing those rapid configs for you. Again, rapid configs could be for automation, could be for security reasons, could be for performance reasons. All of that is out of the box, just check the box and it's done. We'll see, look at some examples of that. And then no two environment is same, right? Even like no two department is same, but no two organization is same. And everyone will have specific challenges, specific use cases. It could be use cases around file integrity monitoring, file integrity control, or execution control, or just having some specific use case where you want specific users running specific application only to be allowed, only for just that. So for those custom use cases, we can always use custom rules. External source, not relevant for Essential 8, but you can actually integrate with network security solutions to provide reputation for files that are being seen on the network. That again, publisher, the reputation is ACSC doesn't say you can't use reputation. It's you can't approve or ban based on reputation. Of course, reputation helps giving us context of the file or what the file could be, whether it could be good or foul, to help us make that decision, right? Of course, you can't approve or ban based on reputation, but you can understand the file better or understand the application better. Again, automation makes everything easy, right? Like things like, again, as mentioned, Linux system performance, basic one. Linux typically has so many applications running on it, right? Like could be your containers, could be the software deployment kits, or there's so many applications running with it. So again, with our experience, we have gone to our customers, asked questions, and understood like what are the things that needs to be approved on Linux to improve the system performance, and then we just put it in one place. So you just check that box, enable it, and we take care of that Linux applications for you. Again, you could edit it, make some changes if required, but even out of the box, it does solve majority of your problem. Things again on the performance side, things like Exchange Server, SQL Server are well known, like for antivirus or endpoint security solutions to make their life easy or hard. So we have automatically created those exceptions for those LDF, MDF, NDF, all those Fs, those extensions, and same thing for Exchange as well. So those automatically gets extruded. We are not looking at those. We are not looking at those as interesting files. That improves the performance of those applications. It could, well, these are just some examples. You could add more. So it improves the performance of those applications as well. Again, things like SCCM or Workspace ONE, once you enable it, anything deployed by it automatically gets approved. Same thing like for your Edge or Chrome, Teams, once you approve it, the users can self-update. Visual Studio is more for the developers. So if you're using Visual Studio, anything they create, any applications they create using Visual Studio automatically gets approved. So you do not have to manually approve those hashes or manually approve those applications. And there are other ways that we can work with your, we can understand, because again, as I mentioned, not two environments are not the same. So you can work with your team to understand how we can use it. Could be just creating a specific folder where they put all those applications and just approving that, or it could be other ways. Now, as I mentioned earlier, visibility is the key, right? You need to have visibility of not just executables, but each script types or anything you find interesting, DLLs or EXEs, of course, or it's on Windows and Mac, on Linux and Mac, it would be different file types, RPMs and all. You need to have the visibility of each and every application or interesting files running on your computer so that you can make an informed decision what I need to do about it, or do we even need it? Is it in my IT security list of approved applications? If not, at least I can add it there and then make a decision later. But you need to know first what's there. Now, to implement everything, it's very important to first understand how do I identify the files, or how do I even go about implementing app control. So common ones are by name, which means like name or path, by hash, again, could be MD5, SHA-1, SHA-2, 6, any hash, and by publisher, right? So these are the most common ones, and these are the most mostly used. So again, each has the pros and cons. Pros, name, definitely most convenient. Just put the name as get over with it. But no, anyone can change the name. If you put a location, even program files is 2 locations, program files and program files x86. So, and then, locations can be anywhere. The user has the option of moving it to D drive or anywhere else. So that makes it really, really difficult to know that everything is covered. You put a name, all those files are covered. You can't do that by name. By hash, again, it's good. It's very, all the hashes are unique. Once you ban by hash, it gets banned. Approved by hash, it gets approved. Location independent, but it's very difficult and it's almost impossible to implement app control just by hash. It could go in hundreds of thousands or even millions. And it's, hashes, you can't go back and check what was the file for that hash. And it just makes it very, very complex. And once anything messes up during the implementation, it's nowhere to correct them. I had a case where approved list went into banned list went into approved list and got merged. And then they had to just scrap the whole thing because it was no way they could, of course, they had to scrap the whole thing, go back to the previous versions, etc. But it makes it very, very, very challenging. Publisher is the most easy one, provides authenticity, location independent. Cons, well, not everyone signs the applications, not even Microsoft sometimes, or any other vendor, not just speaking on Microsoft, but like they are the main ones, the OS vendor, right? Like sometimes we see even Microsoft updates to application not signed. And it could be with any vendor, right? And the worst thing is, and this is, we are getting this a lot, well, at least for the last couple of years since the SolarWinds, etc., is who is securing those publishers, those certificates, right? We are relying on the vendors to secure those code signing certificates. So again, even if you don't want to, there is not much option there if you go with publishers. What if we could do something different, right? That's where content-based inspection comes in. And that's where it provides you the flexibility of doing anything you want, not being limited to path, hash, or publisher. Just, I could just mix and match or come up with my own requirements. Like can I use product name, product version, product name, DLL, is it DLL, driver, executable, file size, file name, build time, signature information, or again, a combination of multiple things. It could be more things like checksums. There's a lot of indicators within a file or file types that you can actually choose from. And that gives you that flexibility that you're not limited to specific things, right? Now let's see how we do it or what we do over it. Some use cases, very simple, file tracking. For example, you're looking for a specific type of scripts. For example, HTML, right? So HTML by itself is not executable. It's not even a very common script, right? Common scripts would be your hash, bash, PowerShell, etc. But so to track HTML, you can just add HTML and start tracking all the HTML files. So whatever files you want to track, whatever files you think are interesting for you, you want to track them, you can actually just use the content-based inspection. Installer detection. Installer detection is very, very important. The reason being, installers are not normal files. I remember the days where you had those service pack installers, that one exe, about 1.3 gig, 1.2 gig exe. The problem is that exe will have one hash. The moment you double click on that exe, it will extract thousands of other files. Everyone will have their own hash. So if you only approve the top hash, everything else gets blocked because they are not approved. So by identifying as installer, well, things like MSI is automatically tagged as installer, again, using those YAR rules. But even for other files, by tagging it as installer, what we're doing is we're not just approving the top file, but anything that it extracts and installs automatically gets approved as well. Ransomware detection, well, everyone knows about ransomware. It's a bad thing, but to understand the indicators of ransomware, right? To detect volume shadow copy deletion, right? Like this backup deletion or changes to master boot record or changes to specific file types, or even within a script, even within a PowerShell, you can say download command is not allowed, or bypass command is not allowed, or specific commands are not allowed. Right? So you can actually go to that level and detect and control it. File classification, just classifies different file types. You can actually build your own classification as well. And the thing with Yara is it's not new. It's been there for ages. I've been there for 16 years doing security, endpoint security for 16 years, but Yara like has been there for ages. I don't even know for how long it's been actively used, right? It's something loved by security professionals. I can say it's a simple scripting language, but the thing is, you don't have to. Anything that you think about, there is a script already there. There are hundreds, if not millions, at least hundreds of thousands of Yara rules already out there on GitHub and other places that you can actually use. For any use case that you can think of, there's already a Yara rule for that. All you need to do, copy, paste, and done, right? Again, and it's looking not just for file hashes, publishers, it's looking for much more. It's looking inside that binary and looking for patterns and, inside the binary. So that gives us more pinpoint and accurate detection or accurate classification of the files itself. Again, we have some out-of-the-box Yara rules, mostly for identification of script types, interpreter types, portable executables, installers. Again, these are just example lists, right? But again, you could add any Yara rule, just add Yara rule and copy paste the Yara rule and create a Yara rule for yourself. Let's see some examples, right? And these examples are more relevant to our Essential 8. So that's why I just picked these examples. For example, approve GoToMeeting. Yeah, I need to approve GoToMeeting updates without approving the publisher. Why? Because GoToMeeting, the publisher itself, can have different applications inside it that you don't want to use, like LogMeIn, for example. So again, you can just say, approve files. So you tag it as approved, product name, GoToMeeting, and subject contains LogMeIn. So only LogMeIn for GoToMeeting gets approved. And because it's, so you don't have to do anything else, right? It's approve as a tag that automatically approves the application. Ban malicious software, right? So that's the most common one. Again, here I'm talking about TrickBot Trojan, but there's so many Yara rules, and most of the Yara rules actually for malicious software identification, malware identification, and blocking them. So, just tag them as malicious. It's a reserved tag. Again, I have not created this. This is just, like the Yara rule for the TrickBot Trojan. It's looking for specific things within the content, strings within the content. And based on that, it will automatically tag it as malicious, which you can actually decide whether you want to ban malicious files or just alert on malicious files, because you would still have your AV. Again, if you could, as I mentioned, you could actually choose to ban if it's malicious, or just tag it as malicious so that you get alerted. You have you have reports, etc. So more from reporting and alerting perspective, or you can just ban it. Now, this one is an interesting example, and lately I'm getting a lot of customer queries for this specific use case. And in fact, just last week, someone called me for this use case, and this is for Essential 8, not from app control perspective. It falls into user hardening and other things, where I just want to approve or ban a specific version of the software, right? And the most common one is Adobe Acrobat, even though we love it, but we know it's buggy at times, the older ones. So again, just a sample rule, right? Again, it's not it has to be this way. Sample rule is, I just gave it a name, vulnerable Acrobat, right? Description is whatever. And I'm just said like, yeah, Acrobat DC and this specific versions, identify, tag these versions. So I can either approve just these versions or ban just these versions. I can even use like greater than, equal to, or anything lower than this one, then just, ban it, or block lower than this, or block anything above this. So again, that's, you can decide based on your use case, right? What exactly you're looking for, what versions you want to allow. So that what it will do is simply allow only those specific approved versions that you're allowed to run in your environment. Anything new or anything old automatically gets blocked, because even new versions, most of the organizations don't allow unless it's properly tested and tested against all the other applications. Only then you are allowed to use. So it takes care of that challenge. And that is one of a big challenge from Essential 8, not under app control, though. It's under user hardening. User hardening or something else. Got that. So again, simple, you add a rule, and then based on that, you could actually, under action, you could block it, alert it, based on what action you want to take on those files that are tagged, right? You can allow it if you want to do the opposite, and that would be your tag, right? So again, these are just some examples. This I could think of are the most common ones, but again, there's so many more, so much more that you could do with the other rules, or just things like identifying all the macros, right? Because that is also a part of Essential 8 macro and Office. That's part of the Essential 8, right? So you can actually use those. So again, it has unlimited capabilities. Now, talking about the architecture itself, of course, it's an on-prem solution. So we get a lot of like, oh, it's on-prem, so that means our work from home or our remote branches, they can't really work. Not true. So mostly we have seen three major types of implementation. One is a standard implementation where it's on-prem within the data center, taking care of all the servers in your environment, in other data centers within the organization, right? And once the user goes home, it has the policy. It's just that it doesn't update new policies. But then the next day when it comes back, it will update the policy and it works as normal. And there are some break glass options that even if they're at home, not connected, they can call or get a service ticket and get a code and get the problem fixed. But the other ones are, and especially since COVID, it's been like, how do I take care of my work from home, right? So things like reverse proxy is the most common one. Even though it's within your data center, use a reverse proxy. We use your custom scripts, custom certificates, your own certificates for communication. And then all the sensors, all these remote computers can connect back to the app control server using the reverse proxy, right? So that's one of the most common ones. And the other one is just put it as SaaS, right? Like put it on your cloud. Could be any cloud, right? Put it on the cloud and just use those, so it just works as a SaaS. It's just as simple as that, right? So it's in terms of implement architecture, it has just one SQL database and the server. Normally, it sits on the same server to reduce the performance, increase the performance, not reduce. And then, of course, you can actually deploy it on any cloud and actually use it as a SaaS server. Then we have customers where they have multiple environments, or it could be in different countries, and you don't want like something in Australia to talk to some, like an endpoint in Australia to talk to server in US or vice versa. So you would have one server here, one in Asia, one in Europe, one in Middle East, one in US, things like that, right? And then you can actually manage all of that from one place, right? So again, from anywhere you can manage everything. And when I say manage, it's not just view, but change policies or anything you want to do on the other servers can be done from one place. Again, multiple countries is one use case. It could be multiple air-gap environments because app control can also be deployed in complete air-gap, doesn't need internet at all to function, right? And you can have like those multiple air-gap environments that you have one centralized console where you're managing all those different environments, right? Or it could be MSSP, as an MSSP partner where you have multiple customers that you want to manage and provide service for. Now let's talk about the approach for implementation, or let's come back to the core of the session, how to get it implemented in a week, right? Or this is an example, right? Again, as I mentioned, no two customers, no organizations are same, but this is something we have seen getting done, right? Like, so this is not impossible. We have seen customers do it. Again, it doesn't mean that you have to do it in a week, though. So even before that, it's before we get into step 1 to 3, it's important to know that our implementation approach is not yes and no. It's not allow and block. It is because it is like a tune, right? We can actually tune it to understand do I just want visibility? Do I just want to see everything? Who is running what applications, how they're using it, get more context around it before I take my decision. So you can have it in visibility mode. Then turn up a little bit, and then law enforcement. Yeah, I want to see all the visibility, but at the same time, can I have selective blocking where something I see it's not good or I don't want it to run? I can just block those things, but everything else is allowed and just runs as normal. And I can see my approved, unapproved applications. So that's law enforcement. A little bit more is medium enforcement, where by default, unapproved applications are blocked, but the user, again, it could be developers or it could be senior management, where you give them the option is of you can actually you can self-approve applications, so you do not get blocked with something. If something comes up, it's good, you can approve it, and later IT can review it and make a decision where it's required or not. But at that point of time, it doesn't get blocked. You could approve the application itself. And the nirvana state, which is the high enforcement, which means, again, only IT approved applications and scripts are allowed. Anything else is blocked. So, the user will get a pop-up saying this application is blocked by your IT. Give a reason why you want IT to approve it, so they can submit the reasoning, and it comes as a ticket within the app control server, where you can actually review it and see if other users are asking for the same thing, and either approve that application for him, her, or that department, that group, that policy, or for everyone, or just say, nah, not really. You shouldn't be doing that. So now looking at the implementation itself. The server, as I mentioned, can be physical, virtual, cloud, any cloud, right? Air gap, internet via proxy, direct internet connected, sitting on cloud. It could be any implementation, right? That you get the software, so you get the benefit. So it's not even a software appliance; it's just software. So it's completely up to you, up to your use case, how you want it implemented. Enable the scripts. So executables, it's already enabled. Enable the scripts that you want to control. In this case, it's the, of course, it could be your PowerShell, Bash, normal ones. And on top of that, HTML and other things. So again, just enable them. So you're monitoring the scripts as well on top of the executables. And deploy the agent, right? And now deploy the agent could be using SCCM, GPO, Workspace ONE, or any software deployment solution you have. Now, on the endpoint itself, it's important to understand is, again, going back 20 plus years. So we were there when XP was brand new, and even before that. But we still support Windows 2003, Windows XP, Windows XP embedded, and like completely supported, right? And of course, like the 2008s and the later ones, 7s, Vista as well. The point is, you would still be stuck with some of those machines you don't love, but you can't get rid of them as well. So we support them as well, right? So we have a support that goes back to XP in 2003 and all the way to the latest one. It could be embedded OS, Mac, Windows, Linux, anything, right? So you just deploy it. It starts the initialization, starts collecting that information, and automatically approving it, getting you the inventory, getting you the visibility, and then you start taking your actions. Like, so again, as mentioned, initialization takes care of, so there's no disruption. So the point is, anything that was running, we don't want to come and disrupt that, so that there's a pain, right? Or there's anger towards the implementation of this security tool, right? So we want it to be smooth. Sorry, we want it to be, that was my timer. We want it to be smooth. Again, you could approve the publishers, software deployment tools, the self-updating apps, etc. As mentioned, your Visual Studio software deployment, the software development team assigning it a location to upload, monitor it for a few days, and for endpoints, UAT, test servers, etc. Monitoring for a few days to make sure after approving any of these, there's no new files coming in, and if there is new files coming in, approve them as well. And then move to high enforcement, right? So high enforcement is, once you move to high enforcement, is where you are ACSC, Essential Aid Maturity Level 2 achieved, right? Once this is achieved, moving to Maturity Level 3 is not difficult, because Maturity Level 3 only adds your Microsoft recommended drivers and rules. So it's just that you need to be more cautious about that it's not creating disruption in your environment. So it needs a little bit more testing. So you need to give a little bit more patience to moving to maturity level 3. But then there's just a couple of more steps to moving to maturity level 3. So you're almost there, right? And yeah, so with that, you are in the summary. Again, app control stops ransomwares and supports multiple supported, unsupported operating systems. Mac, Windows, Linux has memory protection, tamper protection, file integrity monitoring, device control where you can block USBs or other devices, direct control for PCI DSS, and of course Essential 8, not just maturity level 2, but 3 as well. And yeah, like prevents that unwanted chain, right? And it's not just Essential 8. It does take care of a lot of other compliance. There's a lot of other compliance requirements that needs you to have something like app control from a visibility perspective, from a control perspective, from file integrity monitoring. Could be for different reasons, but a lot of other compliance requirements need you to have app control. With that, thank you. Thank you, everyone.